Okay, so hello everyone. In this video, we will cover subnetting in classful addressing. So, in this video, we will discuss about subnetting and VLSM. What is VLSM? Variable Length Subnet Masking. Okay, so today we are going to discuss about subnetting, and we are discussing subnetting in classful addressing, where we divide IP addresses into different classes. Okay, class A, class B, class C, and class D, and class E that we discussed in our previous lecture. This is one of the most important topics in computer networks, and students very easily get confused about what is subnetting and how we actually divide networks into subnets. So in this video I am going to explain with examples why subnetting is done and what is it, okay, and how we implement it. So don't worry about it. So first of all, the first question arises: what is subnetting? Subnetting means dividing a big network into small networks. This is subnetting. We have a big network and we have to divide it into small networks. That's the simple meaning of subnetting. The first question is, what is subnetting? Subnetting is we have a big network and we have to divide it into a smaller networks. This is subnetting. Simple, very simple. And why do we need subnetting? Let's take a simple example. Suppose we have a big university or big organization. The bigger the organization, the bigger the university, the more difficulties you will find into maintenance. How? Let's say we take an address of class A. In class A, we know that 2 power 24 2 raised to power 24 hosts are possible inside every class A network. This number is in crores. Maintaining and managing all these hosts will obviously be difficult, but if we divide this into smaller parts, then maintenance becomes easy. That's why we need subnetting. Okay, suppose we have a big university with different departments like examinations, placements, curricular activities, academics, and library systems and all. To manage all this, either you appoint one administrator, but obviously managing all this very difficult for one administration. Okay, but if we divide it into separate parts, let's say we make one subnet for examination that handles examinations only, and one for placements which handles placements only, and one for academic, and then we have logically divided the big network into our organization. So here what we did the subnetting. Okay, the network address we take is assigned to us by the internet authority, but what we do internally is subnetting within the organization with our own choice. Okay, so we can make multiple subnets. Each subnet will have its own network administration, so maintenance is easy, managing is easy, and when class A has so many hosts, wastage will be less. So the second advantage is security. If we make different departments and divide them separately, then security will be enhanced. This is the main advantage of subnetting. Now the second most important question: how is subnetting done? How we will do it? So for this, let's take an example. I have taken a network from class C, 200.10.20.0. This is the class C IP address. How do we know that it's class C? From the starting octant. The range is from 190 to 223. Okay, so this is the class C. So you can do subnetting in class A, B, and C. We are doing it in class C because writing the range would be easy. Okay, otherwise in class A and B there are many hosts and writing ranges would be difficult. How many hosts do we have in class C? Total 256, because the last octant defines the number of hosts. Okay, as we discussed in our previous lecture. But how many are usable hosts? We don't use the first one because it represents the entire network, and we don't use the last one, 255, because it is the direct broadcast address. So total usable hosts are 254. So now dividing into two subnets, like let's say now I want to divide these 254 hosts logically into two subnets. The first important point is that whenever we do subnetting, the network bits should not be affected. We have discussed that 3 octants are for network bits, and last octant is for host bits. They should remain as they are. In class C, the first 3 octants belong to the network, and if you change any bit here, in the entire network will be changed. So we fix the network ID and don't disturb the first 3 octants. Okay, we use the last octant. The last octant has 8 position because it's an octant 8 bits. Okay, we take the MSB, most significant bit, okay, and fix it. By fixing the MSB, we divide the whole network into two parts, subnet 1 and subnet 2. We are fixing MSB bit. So in subnet 1 we make the first bit 0. Okay, in last octant we are making the first bit 0, and in subnet 2 we make the first bit as 1. These bits are fixed and cannot be changed. Now we have 7 bits left to work with. For subnet 1, the range starts from 0000000 and goes up to 01111, 7 times 1s. Okay, the first bit 0 is fixed. Okay, so what does it mean? For the first 0000 means 0 and goes up to 01111, that is 127 in decimal for subnet 1. And for subnet 2, the range starts from 1 00000 and goes up to 1 and 11111, and like the first one is fixed. The 1 0 0 0 0 0 7 times 0 becomes 120, and goes up to 1111111 in decimal. Okay, this for subnet 2 the range is from 128 to 255, and for subnet 1 the range is from 0 to 127. Okay, so subnet 1 range is 200.10.20.0 to 200.10.20.127. Subnet 2 range is 200.10.20.128 to 200.10.20.255. This is our subnet 1 and subnet 2's range. Now, for subnet 1, what is the network ID? The network ID we have already discussed in our previous video, that the first one is network ID and the last one is broadcast address. So for subnet 1, network ID is 200.10.20.0 and broadcast address is 200.10.20.127. And what are the total number of hosts? 128. Why? The range is from 0 to 127 and last octant represent the host values, so total number of hosts are 128. But what are the number of usable hosts? 126, because the first one is network ID and the last one is broadcast address, so the usable hosts are 126. Now for subnet 2, what is the network ID of subnet 2? Network ID of subnet 2 is 200.10.20.128. And what is the broadcast address of subnet 2? 200.10.20.255. Now here total number of hosts are also the same, 128, but usable host 126. Overall, instead of 254 usable hosts, now we have only 252 usable hosts, because 126 plus 126, because we have divided into two subnets. So 126 plus 126 usable host means 252 usable host, because each subnet has its own network ID and broadcast address. So that's what the fundamentals of subnetting. Now, what is the subnet mask? We have discussed this in previous video also, that the default mask for class C is 255.255.255.0. But what is the subnet mask of these two, S1 and S2? We have made default mask address for our class C was 255.255.255.0, but since we reserved 1 bit for subnetting in this example, our subnet mask will become 255.255.255.128. This is because we made the first bit of the last octant as followed as 1, okay, followed by 7 zeros, which equals to 128. Okay, now routing between subnets. When a packets arrive with destination 200.10.20.15, the router uses the subnet mask. Now from outside world, this whole concept was in our inside network. From the outside world, when a packet arrives with the destination address 200.10.20.15, the router uses the subnet mask 255.255.255.128. When we perform the AND operation between 15 and 128, we get 0, okay, which indicates subnet 1. Okay, if the destination is 200.10.20.130 and we perform the AND operation, gives us 128, which indicates subnet 2. So we have implemented a inside router also. Okay, we have the outside world router also, and we have implemented a new router in our network also. So we have provided this subnet mask to this internal router. So when a packet arrives with destination 200.10.20.15, then it will decide that yes, this belongs to subnet 1, and this, if a packet arrives with 200.10.20.130, then it will decide that it belongs to subnet 2. Now, what are the disadvantages of subnetting? There is a small disadvantage. The number of steps to reach a host increases. Okay, earlier we had to find network ID and then host ID. Okay, now we have to find the network ID, then subnet ID, then host ID, and finally the port number. Okay, so computation increases slightly. Okay, but maintenance management and security improve significantly. Okay, now the next topic is variable length subnet masking, VLSM. Now we are going to discuss VLSM, variable length subnet masking, which we generally call variable length subnetting. Okay, why do we need VLSM? The meaning of variable length subnetting is that we need to convert large network into small networks, but with the flexibility to make one subnet bigger and another smaller according to our requirements. Can we make subnets of different sizes according to our needs? Yes. We use variable length subnet masking. In normal subnetting, we divide a network into two equal parts. But think about your computer hard drive. If you have 1 terabyte, is it necessary to make 4 drives each of 250 GB? No. You might keep one drive to 500 GB and other smaller. Windows provides us flexibility to make drives of different sizes. Okay. Similarly, our network should allow us to make subnet of different sizes. Okay, now we are taking an example scenario. Let's say we have a university organization. The academic department has more requirements, more users, more hosts, so they need more IP address. For the rest of departments, I can divide them into smaller subnet of different sizes. Okay, now we are taking the same example. We have a class C address. Okay, 200.10.20.0. In class C, how many hosts can be there? 256, 0 to 255, but usable address are 254. We have discussed it before. Our requirement is one department need more than 100 IP addresses and two other department needs more than 50 each. Now what is the implementation process? Taking 200.10.20.0, the 8 host bit are currently all zeros, okay, representing the network ID. Okay, now what is the step 1? Create first division, reserve the first most significant bit and fix it to 0. This divides the network into two equal parts. S1 first bit equal to 0, S2 first bit equal to 1. Now what is the range of S1? Starting range 200.10.20.0, 0000000, and the S1 range ending is 200.10.20.127, 0 followed by 7 ones. Okay, now in S1, how many usable addresses are there? 126 addresses that we have discussed before. This satisfies the requirement of more than 100 hosts needed. Okay, we have fulfilled a one requirement. Now what is step 2? Divide S2 further. Since S1 is complete, we need to divide S2 into two more subnets. For S2, the first bit is fixed as 1. Now fix the second bit. For S2, the first bit is 1 and the second bit we have fixed it as 0. Okay, and S3 second bit is fixed as 1. Okay, so we have divided S2 into S2 and S3. Now what is the range of S2? S2 starting range is 200.10.20.128, 10 followed by 6 zeros. And what is the ending range of S2? 200.10.20.191, 10 followed by 6 ones. This is the range of S2. Now what are the usable addresses in S2? 62 addresses, 64 minus 2. Okay, because the first address is a network ID and the last address is broadcast address. Okay, so usable S2 addresses are 62 only. The range is from 120 to 191 for S2. Now S3's range, the starting range is 200.10.20.192, 1 followed by 6 zeros, and the ending range is 200.10.20.255, 1 followed by 6 ones. The range becomes 190 to 255. The usable addresses here is 62 addresses, 64 minus 2. The first one is for network ID and the last one is for broadcast address. Now subnet mask. For S1 we have to make an subnet mask, and for S1 and S3 we have to make an another subnet mask. Okay, so for S1 25 bits are fixed, 24 original plus 1 additional we have fixed. Okay, so the subnet mask is 255.255.255.128. Why 128? Because we have fixed one bit. So in S1 we have fixed only one bit, so 24 bit plus 1. So this will become 255.255.255.1 followed by 7 zeros. So this will become in decimal 128. So subnet mask of S1 is 255.255.255.128, and for S2 and S3 26 bits are fixed, 24 original plus 2 additional we have fixed. Subnet mask will become 255.255.255.192. Now verification. Total usable address is 126 plus 62 plus 62. This will become 250. Okay, out of original 256 addresses, 6 addresses are lost, 2 from each subnet. Okay, this can be calculated as original minus 2 into number of subnets. Okay, the original number was 256 and the total number of subnets is 3. So we will calculate it 256 minus 2 into 3, which will become 250. Okay, now all the requirements are satisfied. S1 we have needed more than 100, so we have made it to 126 addresses. For S2 and for S3 we needed 50 plus addresses, so 62 addresses for each. Okay, we have fulfilled all the requirements. So this was the whole concept of classful subnetting. This is the very important topic, and you have to learn this, you have to practice this. Okay, so that's it for this video. We will meet in next video. Until then, bye bye.